So, we've just touched on how RAG enables LLMs to process specialized enterprise data. Now, let's dive into the core of what Retrieval Augmented Generation, or RAG, actually is. At its heart, RAG is a technique designed to significantly boost the capabilities of large language models, or LLMs. It does this by connecting them to external knowledge bases. This connection is key because it allows the LLM to ground its responses in specific, verifiable data, rather than relying solely on the information it was trained on. This directly tackles major LLM limitations, such as knowledge cutoffs, the point up to which the model's training data extends, and the tendency to sometimes hallucinate or generate incorrect information. By grounding responses in external data, RAG enhances both the knowledge and the factual accuracy of the LLM's outputs. Think of RAG as a smart intermediary. When a user asks a question, the RAG system first fetches relevant information from an external data source. Then, it provides this retrieved information, or context, to the LLM alongside the original query. This ensures that the LLM's final answer is not just generated from its internal parameters, but is actively supported by the retrieved external data. This grounding is crucial for trust and accuracy. This diagram shows the basic flow. A user query comes into the RAG system. The RAG system then interacts with an external data source, retrieving relevant information. This retrieved information is used to inform the LLM's generation process, leading to a grounded response. The grounding here signifies that the output is anchored to specific facts. Now that we understand what RAG is, let's break down its core components and their specific roles in making this process work. The system functions much like a brilliant individual collaborating with a dedicated research assistant. We can think of the retriever as the research assistant. Its primary job is to scan a knowledge base, which could be a large collection of documents, a database, or other data sources, to find information that is relevant to the user's query. It takes the user's query as input, employs sophisticated search algorithms to pinpoint the most pertinent data snippets, and outputs these curated snippets, often called context. The generator, on the other hand, is like the brilliant individual, in this case, the LLM itself. Its role is to synthesize information. It receives both the original user query and the context provided by the retriever. Using this combined input, it constructs a final response that is not only coherent but also factually grounded in the retrieved information. The output is therefore an augmented, accurate response. This diagram illustrates the interaction. The user's query goes to the retriever. The retriever accesses the knowledge base to find relevant information, which it then passes as retrieved context. This context, along with the original query, is fed into the generator, the LLM, which produces the final grounded response. So, the retriever finds the facts, and the generator uses those facts to answer. We've discussed the components. Now let's walk through the RAG workflow step by step to solidify our understanding of how information flows from query to grounded answer. The RAG workflow is fundamentally a two-step process. First, there's retrieval. The user's query is processed by the retriever, which searches an external knowledge base, often a vector database, to find relevant information snippets. Second, there's generation. The original query, now augmented with the retrieved context, is passed to the generator, the LLM, which then formulates a response using this enriched input. This sequential, closed-loop system is what ensures the LLM's output is directly supported by the knowledge base. By prioritizing retrieved information, RAG significantly minimizes the chances of the LLM generating fabricated or unsubstantiated content. This diagram visually summarizes the workflow. We start with the user query, which triggers the retrieval step. This step interacts with the knowledge base to yield retrieved context. This context, along with the original query, then informs the generation step, ultimately producing a grounded response. It's a clear pipeline from question to verified answer. To fully grasp RAG, it's helpful to understand a couple of key terms that capture its essence: grounding and context augmentation. First, grounding. This refers to the critical process of anchoring the LLM's output to verifiable information sources. In a RAG system, the documents retrieved by the retriever act as the evidence or the foundation for the generated response. This ensures that the answer isn't just plausible, but is actually supported by facts. Second, context augmentation. This is the process of enriching the original user query with relevant information fetched from the knowledge base. By providing the LLM with this additional background, it gains the necessary context to formulate more informed, accurate, and relevant answers. This diagram highlights these two concepts. Grounding means anchoring LLM output to verifiable sources, with retrieved documents serving as direct evidence. Context augmentation means enriching the query with external information to give the LLM better background for informed answers. Together, they ensure accuracy and relevance. We've covered the fundamentals of RAG. Now, let's briefly touch on what makes a RAG system truly effective in an operational setting. The overall effectiveness of a RAG system hinges on several key dependencies. The retriever's accuracy is paramount. If it can't find the right information, the rest of the process suffers. Equally important is the generator's ability to synthesize the provided context. It must be able to effectively use the retrieved snippets. And fundamentally, the quality of the underlying knowledge base, the data source itself, is crucial. If the source data is poor, the RAG system can't produce good results. It's also worth noting that more advanced RAG architectures might involve iterative retrieval and generation steps, or sophisticated re-ranking of retrieved documents, to further refine the output quality and ensure the most relevant information is always used. This diagram shows how retriever accuracy, generator synthesis, and knowledge base quality all feed into the overall RAG system effectiveness. Poor performance in any one of these areas can significantly degrade the system's output. So, the key idea is that RAG effectiveness depends critically on the quality of its components and data. With these fundamentals in hand, you're ready to explore how to implement and optimize RAG systems in practice.